Wait a second. Isn't electric and aviation a hot topic? Chris, do you want to take that one? Like, what do you prefer? I heard it
I
was like,
Yeah, I'm either going to go broke or die trying. We can't just go build an airplane and fly it around. In fact, that's like the quickest way to get on
boo,
a list you
boo.
don't want to be on.
Hey, this is Air Mobility Show with Amad Malik and my co-host Nadia. Hey Nadia, how are you doing today? You just came back from
Hi,
the
Ahmad.
from some time with family. How are you feeling?
Yes, very good. It was a good time in the US. Now fully back in the UK. Better weather, by the way, and very excited to be here today. I think as we move forward with exploring the world of the advanced air mobility, we find ourselves in very, very interesting areas. And I'm excited for today's episode because we will be talking a lot about different type of aircraft.
As you know, the advanced air mobility is much wider subject than just eVTOLs because that's what people think it is, and it's exactly, Kevin. So it's a lot more than just eVTOLs, and I think this is a very important thing. In my view, this is precursor for what I think aviation 3.0 should look like. And one of our friends, Kevin, he have started a new company which is kind of focusing on these technologies. So welcome, Kevin, and welcome, Chris, who is also the technical lead or the geeky guru, if you may,
Yeah.
of the company. So very exciting to have you both on board. Welcome.
Thank you, thank you. I'm actually excited because I'm going to change my business cards now to Geeky Guru because that sounds so much better and so much more approachable as a person if they know I'm the Geeky Guru.
Indeed. Yeah, no, I'm glad to give you some some ideas. So Kevin, let's get started with just a quick introduction to yourself and the company and how this all came about and how you and Chris
Yes.
got started with this. Yeah.
Oh man, yeah, our love story. Yes. So CEO and founder of Anatra. And Anatra is Italian for duck, which is the amphibious UAV. We share a vision where we are going to be the best and the number one cargo UAV manufacturer for the world. And so, with that, I came across this geeky guru, and I can't tell who's crazier, me or Chris. And we met, and I told him the vision of what we can do for advanced air mobility, and he said, say jump, and I will. And so we've been locked in for, I don't know, what, like 2 years now. Chris, feels like
Yeah.
just yesterday. So it's been really fun to try and push an industry and build an aircraft that sounds really simple, but turns out there's a lot to it. So
Yeah. Kevin approached me and he's like, "Hey, I've got this really challenging problem. I have no money, just big ideas. Do you want to go on this journey with me?" And I was like, "Of course. Why would I not? Sure. Long hours, no money, no pay, but we might change the world. All
Yeah.
right, sounds good."
That's the way to go. That's the way to go. I mean, this is the
Yeah.
thing, I keep saying that, um, and I think my viewers are going to get sick of. Sometimes I keep repeating some things too much, but the aviation was built on the shoulder of people who have passion for flying, passion for this technology. From back in the day, from
Yeah.
twenties, when no one wanted to fly, they were like, "This is unnatural. We leaving the ground." That was the idea, and then
Well,
it just kind of evolved from there, and look where we are now.
if I'm correct, right? Like the Wright brothers started by building bicycles,
Yeah.
I think. Weren't they building bicycles?
Yes.
Yeah.
And one of them said, "Hey, hold my beer," and I'm gonna go build an airplane.
I think
You know,
that's absolutely right. And if you look at
that might
the
not be 100% accurate, but yeah,
yeah, but I mean,
you
if
know.
you look at the original designs, they were like more made up of spokes and chains and wires.
So it takes passion, a leap of faith. You have to be risk tolerant and really believe that technology exists now that can be properly applied, and you can really do something with it. The idea that Kevin came up with for the amphibious seaplane, it's really not far fetched. It's not like we're inventing a new realm of physics that needs to be applied. This is practical technology, practical engineering that will create a vehicle that will have lots of use, especially in uncrewed or unmanned cargo movement.
Would you please tell us more about the two type of aircraft that you're building more in detail?
Yeah, it's actually two of them. There's a runway to runway, so standard, familiar with aircraft. Now take the pilot and the passenger and put a 500-pound payload, and then make it uncrewed, and there you go. And now you have we call it the Piro or the LC, Land Cargo 500. And so that one is something I think you're very familiar with. So that one is kind of, once again, we believe the technology should already be here, but here comes the hard part. And then yeah, the seaplane, we call it the Spady. We believe that our aircraft could one day be used for disaster relief or rescue missions, and there isn't a place we won't be able to reach. So that's our vision.
Places like island economies, island nations, where it's vital for them for not only survival but also to make sure that there are always enough supply of things like medical needs and food and all sorts of emergencies. So that's a very interesting use case. But how do you see the inception of the first use case of your aircraft?
Right, the amphibious one, so well said on that. Our we made at Moment, our vision in the future that, we feel the reason we're pushing the industry and we're making this aircraft is that people who are in remote areas can be tapped into the economic development of the world. And so if you have a farmer in the Philippines who wants to grow and have a sustainable farm but doesn't have that infrastructure to ship the coffee beans that they want to ship every day, you can use our amphibious one that comes right in, and every day you're going to have 500 pounds to, depending on how many you use, 2,000 pounds, and they take their phone and pay in crypto. Just kidding. But anyway, it's a fun way to where now you can, it's really fun to look at that maritime aviation kind of logistics. And now no matter where you're at, you can be tapped into commerce. Short term, it's funny you mentioned that we're actually going to go national security and defense first. So there is going to be a need on the defense side for some amphibious contested logistics, and that can be used in rescue missions as well, and other civilian cases. But we're definitely focusing more on the defense route.
Um, Very good. And how about the other aircraft that is the runway to runway?
Yes, middle mile is the majority of the focus on that one, and
Hmm.
and yeah, there's some cases where it might be a dirt runway. It is definitely rugged.
And do I imagine it correctly that the companies like Amazon Air or DHL would be the potentially the fleet operators?
Or there's a company I believe that's in your backyard called Dronamics, which they're already
Okay.
doing uncrewed vehicle deliveries, and their aircraft is
Hmm.
called the Black Swan. So
Hmm.
ours is a duck, and so I think there would be a fun little, hey, look at this beautiful addition that we can do with
um,
all the deliveries. But yes, you nailed it on the head on that one. Yes.
Focusing on, I think, transfer of goods and rather than concentrating on a taxi or people is a very good idea, because I think that's something that can be um, adopted right now immediately with less sort of scrutiny or data. But from a technology point of view, you're testing one prototype right now, but that's a normal aspirated engine aircraft, right? Is that the plan? Is to go electric, full electric, or hybrid, or what's?
Wait a second. Isn't electric and aviation a hot topic? Chris, do you want to take that one? Like, what do you prefer? I heard it
I
was like,
Yeah, one of the reasons that Kevin and I got hooked up was some of the technology that we've developed in my normal job before when I'm not with Anatra. So we work a lot in electric aircraft, both on the power side, developing battery technologies, energy technologies to support electric aircraft. I'm talking about Hika, actually the shirt I'm wearing, obvious plug. Nice bright. Actually, I just got these new shirts. I had to go to pink. We have a lot of women in leadership at Hika, and I was told that we need to have some pink colors, and I'm all
Make
for
it
it.
more
Especially it's
exclusive. Yeah.
women's. It's International Women's Month, I believe.
Yeah.
Year.
Just FYI.
Year.
So one of our technology verticals is battery management, batteries, electrification, advanced technologies to support the immense power consumption and delivery that's needed for aircraft. And then on the other side of the house, we have a technology suite that supports development of the controls, algorithms, the flight dynamics, all the stuff that makes the aircraft actually fly from an electronics software perspective. And there's a lot of automation and AI built into that. And we took those technologies to support basically rapid development of aircraft and try to shrink that design cycle from 10 years. In almost any aircraft, even the eVTOLs, they think they're going to do something in 3 years. It's really 10-year development cycle from concept to certification, right? And we're trying to shrink that down into a year or two. Using a lot of AI and automation in the design cycle, and then coupled with electric power. My personal belief as an engineer first is electric is the way to go for a bunch of reasons.
What?
Yeah, and electric because the motors are less complex. You have much less maintenance, repair, overhaul of an electric motor compared to an internal combustion motor. You get a lot more torque out of an electric motor, and that's the pros for an electric aircraft. The cons, is the energy density is not quite there, right? The the total amount of energy per volume or per weight is not the same as avgas or jet fuel. So we still have a little bit of ways to go before we'll be able to store enough power to make it super comparable and obvious the winner for long distance. But for things like what Anatra is doing with the 500 pounds and 500 miles on a fixed wing aircraft, it's very possible to do with electric, especially coupled with a small hybrid generator to augment some power during flight, right? Most of your power is consumed during takeoff and getting up to, and during climb. Once you get up to cruise, you power back down. That part's fine. So if you could augment your stored energy with a small generator, that you get the best of both worlds. I think I really believe that's the way to go.
But I'm
Yes, Kevin.
scared. Are you saying electricity and like the sea and the ocean can go together? Like why would that make sense to put it on our, amphibious cargo UAV?
Well, some of our current customers right now are maritime boats. So we're actually developing battery, and
Oh,
in fact, like Anatra is going to win out here because they're going to get tried and proven technology that's out fielded in a very austere and challenging environment that's marine, and so it's not first to use, right? And then the second is I really hope the aircraft spends most of its time in the air and not on the water and
hey,
not submerged at all by anyone. But I think salt water. People are afraid of water and electricity mixing. It's really, I mean,
Mm.
there's there's tons of applications of high voltage stuff on water. Yeah.
is it less maintenance or more? 'Cause my seaplane operators, oh Lord, they complain about having to wash that aircraft down every time it comes into dock. Would you say it would be easier if it was all electric?
Oh, for sure. I mean, electric motors have basically one moving part, right? Like that. If you ever look up an electric motor, there's two parts to an electric. There's two parts to any electric motor. There's the stator and the rotor, and it's kind of easy to remember. The stator is the stationary part of an electric motor, And the rotor is the rotating part of an electric motor. That's it. It's got maybe some bearings in it and some grease, but there's really nothing to wear down. And if you've ever owned a Cessna or any pilot that has had to deal with maintenance, repair, and overhaul, they know like every so many 100 hours they have to bring their plane in. You've got to pull all the spark plugs. You've got to do a complete engine teardown and overhaul, what, every 500 hours or 1,000 hours. So, and there's so many parts. There are so many parts to an internal combustion engine. And an electric motor has two parts and maybe a bearing. There's just not enough stuff on it to go wrong.
With the electric motor, you also have the controller, and the controller have thousands and thousands of parts, which make it more complicated than an internal combustion engine. So what do you think about that?
There are electronics parts, right? There are resistors, capacitors, MOSFETs. I mean, they're basically small electric components, right? And they're solid state. They don't have any moving parts in them. Um, they very rarely go bad. They only go bad in extreme circumstances where they get damaged. And they also are very cheap and replaceable,
Mhm.
generally speaking. Um, and in fact, it's one of the areas that could, over time, lead to improvements. The electronics, the controls, software and electronics will increase in performance over time, just like the batteries.
Yeah.
And those are a line replaceable unit that, maybe in 5 years, you unplug it, plug a new one in, and you get 5% gain, efficiency gain, or something like that.
Do you think since we don't have passengers or a pilot, this would be a great way to show the technology on how safe and reliable it is? Like we could almost help the industry be the, first leader in like what
Right.
this new technology can do. Is that what you think the vision?
Yeah, I believe so. I mean, it's all about flight hours, right? Like, if we can get 10, 20, 100, 1,000 of these things just building flight hours in a very safe and controlled way. Um, for instance, like to Nadia's point, island nations that delivering cargo, um, from runway to coastal, beach, or to dockside, or dockside to dockside, and these planes are just flying, and they're safe. Like, the other great thing about flying over the ocean is there's not a lot of stuff to have an accident, to hit. So it's almost like the perfect test ground to prove these technologies, right? If we take off from a dock, we fly over the ocean open, land, and then pull up to a dock, unload cargo, recharge, and fly back. And you're doing this over and over and over again. You're doing it in an environment that, from a safety aspect, there's not a lot of risk, very, very little, probably the most minimal risk you can to life or personal property. Here's one other thing too. If you think about the future of electrification in aircraft,
Mm.
internal combustion engines, right, are not going to keep getting that much better.
No,
There's
no.
not this like giant curve to getting better. But energy storage, electrification, like people are like, oh, batteries don't have enough storage, but they will get better. There's plenty of room for those, for battery technology to increase. Motors can get more efficient. They're already pretty efficient, electric motors, but they can get more efficient. Storage. So even if we can't build the perfect electric aircraft now, 6 months from now could be a total different world. And then 10 years from now, it's going to be even better, right? It's going to be, in 10 years from now, we're going to look back and be like, why did we ever use internal combustion engines or on an aircraft? So whoever's in it now is going to lead the way.
But what about, now I'm nervous since we have the electric side figured out. We don't have enough pilots to do all that, right? So is there a technology that would allow, I don't know, an uncrewed aerial vehicle to like take place? Make me feel comfortable about that because I'm kind of scared. Is that technology already here? Is it working?
So
I'm loving it.
that's a very challenging question. That because that's to be able to do that is the amalgamation of all the technology. So right on the aircraft itself needs to have sense and avoid capabilities, right? So it's got to have the right sensor suite. It's got to have enough, intuitive, autonomy software to be able to make some decisions about navigating and piloting itself in some situations. Obviously, like collision avoidance is a big one, because how do you integrate an unmanned system into a manned system where you've got pilots making decisions, but then computers making decisions on, I think that the technology does exist now. Like, we definitely have the technology now to do this completely, have everything be autonomous, have air traffic control managed by computers. Planes should be able to fly themselves. It's getting all of the players, it's getting all of the vested parties
to come
on
together.
the same page and saying, this is the path forward and this is what we're going to do.
If only there was a podcast that would get all the influencers on talking about advanced air mobility to really educate and
Yeah.
have fun. Man.
Oh my
would
God,
be-
that's a brilliant idea, Kevin. Somebody
Tell you
should do
what.
that.
Tell you what,
I'm definitely going to
would be
start that
great.
podcast, Kevin. Fantastic idea. I think this is
Okay,
today.
yeah.
Today is the start of the Air Mobility Show. I just came up with the name.
I love
Oh
it.
my God, that's so much fun.
And part of it, like when I put my technology hat on, right? Like, I've argued this, that we have the technology now,
Yeah.
right? And really, I think part of the holdup is more on the financial aspects of it. I told somebody recently, like, there's a reason why your pizza is not being delivered by a drone right now. Like Domino's or Pizza Hut, they're not buying drones and using them to deliver pizza because the cost benefit's not there yet, right? The technology to have an unmanned system and the platform and the technology to be autonomous and safely deliver your pizza is probably hundreds of thousands of dollars, maybe $500,000, and to the local pizza place operator, he can't afford that, right? It's cheaper to hire a high school kid with a car. But that technology is going to continuously get cheaper and cheaper and cheaper, right? And it's just going to plummet. And at one point, we're going to cross that cost boundary to where, okay, now it makes financial sense. And then we'll see larger players come in, I believe, that have the pockets to sway regulation. They'll have the financial wherewithal to be able to sway those that make regulation to force adoption of a universal air traffic management system. Ultimately, the technology is going to be much cheaper, right? Like, man, you can buy a laptop now for like $200 at Walmart when, 15 years ago they were $2,000. So now everyone gets a laptop, and look how far it's come.
No, I think the whole thing is very exciting. I mean, if you look at where we are as humans in the known history of humanity and what we are able to do right now, is just very, very exciting.
Yeah. And then if you look at it on a expanded timeline,
Yeah.
and you look at the speed of advancement, right? From first flight to today, the fact that SpaceX is putting up rockets twice a week, 3 times a week now,
Yeah.
putting satellites in orbit. Like, to go, if you look at that on the grand timeline of how fast technology is coming at us now and how fast it's moving,
Yeah.
it's inevitable.
Yeah.
These things that we're talking about today are inevitable.
Yeah. No. Absolutely. Absolutely. And what is your view of air control, traffic control, urban environments, and so on?
Yeah, I think that's a true unknown. How are these things going to operate? Whether, especially like big cities, right? Too, um, or urban, very urban environments. I think obviously urban environments will be easier. There's less things to hit, but that's a big unknown, and that may be one of the most challenging aspects of how we integrate there and how we make that work.
Chris, would you say that it might help if you went like maybe defense first to kind of show like what it can do to then roll it out maybe more wider? Would you say defense would be a good maybe pathway?
I do. I personally feel defense is, well, it gives companies that have these innovative technologies kind of two benefits. One, every government wants to be the best, right? Like, they want to have the best possible equipment, the best possible advantage, and so they are less risk adverse to investing in new technologies. It's pretty much all new technology comes out of defense, right? And then second, like for us in the U.S., it gives companies like Anatra the opportunity to operate in areas that are urban and can prove those use cases out, or remote. Island nations in water, we can operate in, you know, other continents that are very sparsely populated that have some kind of strategic or defensive position that we need to augment. It gives, in the U.S. it's very tied down and restricted. We can't just go build an airplane and fly it around. In fact, that's like the quickest way to get on
Boo.
a list you
Boo.
don't want to be on, is to build an airplane in your backyard and then go fly it.
Yep.
But I think defense gives us that ability to start generating that data. And we talked earlier about we don't have the data. We need to start actually flying, collecting flight hours somewhere, wherever we can, that we're allowed to legally, and collecting that data to show the safety and the efficiency of being able to do what we want to do.
Expanding from that, what do you think about getting into some competitions to showcase your technology? Is that something that you would be interested in? I think Kevin, I mentioned it
Oh, I would
last
love
time. This races that are starting. You ever heard of Pulitzer Trophy, right?
Yeah, they're trying to rope us into that one. So,
Rope
we're
us
gonna
into
have to. Yeah, I said we'll see what we can do. I don't know if you've noticed, but Chris and I say yes to everything. So, we'll see. We'll see.
and I'm very competitive. I want to win. You know, it's very difficult when someone says I challenge you. I almost like immediately say yes, and then I say to what? Um,
Yeah.
Challenge
Yeah. Well,
accepted.
it
That's
gets me
great.
in a lot of trouble.
So what's next for you guys? Which stage you are at with the flying duck? Because I would really like to see a version of that I can fly.
we're still in development stage. I think we're actively raising capital to continue, and we're on that runway, pun intended. So yeah, I think only if you look at the commercial side, they say it only takes about $90 million, but no, yeah, we're perfect story, perfect vision. We hope to get that to you in 2 years, and so we're down that path, and I hope we share this to investors who would love to make that dream come true. There is a great new nonprofit we could help after the fact once we're successful and we push that advanced air mobility. So yeah, I think I would say 2 years. Chris, am I wrong on that? 2 years out. So
Yeah, I'm either going to go broke or die trying or be successful. So I guess that's three outs there. No, but we will be successful, and it's not going to take $90 million. I've been in this side of I've been in engineering and technology and around aircraft design and development, and especially on the controls and electronic side, and figuring out how to make something fly. Um, in fact, like I had an earlier discussion earlier today about our whole engineering philosophy on how to build something, right. And we have a 3-step. Forget all that stuff you learn in school about how to engineer, right? Waterfall method or agile method, or now there's our method, right? And it's 3 steps. You make it work first, and it could be ugly. It could be a airplane with an iPhone taped to it, right? That's fine. Make it work first. You make it efficient second after it's working, and then you make it sexy third, right? And then that's when people really buy it. And that's kind of our philosophy on engineering. It's the we don't have a name for the process yet. Maybe it's the Anatra process. Maybe it's the Hika process. But it's a 3-step process, and we're throwing away, not throwing away, but we're changing the way aircraft are designed and developed. We're using a lot of AI and automation, and that's why I know we'll be successful. And in fact, we've already kind of proven it. Not to, you know, this isn't magic. It is real.
Well, I can tell you, the positivity that I've seen with you two is infectious. Is really, if anyone can do it, I believe you guys can. And I'm completely
I
rooting
appreciate
for
that.
it. I'm completely rooting for you
Thank
guys,
you.
and I'm so excited to one day see it flying. Please don't forget to invite me when you have your inaugural flight. It was a pleasure, Kevin, meeting you and Chris as well. Uh, the conversation was very fantastic. I mean, I can tell you right now, this is one of my favorite episodes. This is fantastic conversation. I
Oh,
mean,
awesome.
I
Thank
didn't have
you.
to do a lot of hard work,
Yeah.
Kevin, you just took it over. Fantastic. It is. I was loving it.
We can invite you to be the co-host of the show one day.
Exactly.
There
That's
you
probably
go.
what's going to happen. We're going to have you as a co-host, start interviewing other people as well. Love having you here. Really, really appreciate your time. And also thanks to all the viewers who signed in and who are watching this podcast, who have made this podcast a success in a short period of time. Really, thank you very much for everyone subscribing and watching us. And we'll see you next time. Bye-bye.
Awesome. Thank you so much.
Thank you.
Thank you.